Yes, it's a chemistry of the electrodes inside the cell. We need to do a good job of engineering the electrodes on the nanoscale, and we need to do a better job of providing stable and safe electrolytes. And part of my effort is exactly on developing those electrolytes.
Now, do you think, I've heard that lithium phosphate, well actually I know, but I've heard that lithium phosphate has certain issues with extreme conditions such as cold weather.
Yes, operation under either extreme warm or extreme cold conditions is always a problem. Under extremely warm conditions, you run the risk of having undesirable chemical reactions. Under low temperature conditions, you're concerned about the power capabilities of the battery because of lower conductivity of the electrolyte and slower electrochemical reactions.
Everyone seems to have different numbers and different opinions on the availability of the resources.
Yes.
These batteries. Now, what are your thoughts on the availability of the resources?
Well, lithium is widely available, and there are many resources in many countries around the world. And right now, the production rate of lithium is not determined by the resource availability, it's just determined by the demand. So I believe that lithium will be available in sufficient supply for future batteries. Sulfur is a huge resource. It's very inexpensive. It's about 30 cents a pound. And right. And there are literally mountains of pure sulfur that are just sitting there because there isn't enough demand. So the production rate of sulfur can be very high and the price is very low. Thank you.
Is the electrochemical stable of the plant work, and that is suitable for use in those high voltage cathode material. This show the effect of the filler content on ionic conductivity. And we can see at room temperature the addition of the filler and its ionic conductivities of the membrane that shows the addition of the filler has a positive effect on the transition properties at room temperature. And the room temperature ionic conductivity of the 5-8% filler continuum membrane is also 1 to 10 minus 6. And when we increase the temperature, say is 50 degrees C, you can see the difference between the smaller and smaller. That means at high temperature, the effect of the filler on the ionic conductivity is less significant. And you can see at 80 degrees C, all these samples show a similar ionic conductivity. And this may be caused by the reduce of the viscosity of the ionic liquid at high temperature, and this can compensate the positive effect of the additional fillers. And then that's the battery performance test. And in this case, I have used the lithium iron phosphate. That's one of the low promising chemical material in current to use in electrochemical. And we can see that it shows output capacity at a low C rate. But at high C rate,